بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. These are some exercises about section 7.1 integration by parts. We mentioned to choose u. Of course, let me remind you with the formula. The formula is we write the integral in which usually we have product of two functions, although we can use integral by parts in other cases. We try to write it as integral u times dv, where u is a function we need to integrate and dv is a function we need to u is a function we need to differentiate, find the derivative, and dv is a function we need to integrate. So integral u dv would be equal to integral uv minus integral v du. And how to choose u and dv? So we will use this uh, method, layet principle, to choose u, to select u. So L from logarithmic, if we have a logarithmic function, immediately we choose it as u. It has the first priority. Then inverse trigonometric functions I, then algebraic like x or square root of x or 1 over x, okay, algebraic functions, and then trigonometric functions, sine, cosine, and exponential functions like e to the power x. Inverse trigonometric like sine inverse, cosine inverse, logarithmic ln x, log x. So using this principle, we select u first. So for example, here I have an algebraic function. Square root of x is an algebraic function, and ln x is logarithmic function. So layet L comes first. So I choose u equals ln x. And then I find the derivative of u. The derivative of ln x is 1 over x dx. I choose dv, the next part, okay, the remaining part of the integral. So ln x has gone. Now I have square root of x dx. So square root of x dx. And I find the integral of dv, that's v, and the integral of x to the power half is x to the power half plus 1 or 3 over 2 over 3 over 2 or times 2 over 3. And then this integral, which let me call it I, would be equal to u times v. So I multiply these two, u times v, which is 2 over 3x times ln x minus integral, this one, v times du, okay? So 2 over 3x times 1 over x dx. Notice that x cancels with x, and the final answer would be 2 over 3x ln x minus integral 2 over 3, and integral 2 over 3 is just 2 over 3x plus c. So this would be the answer. Integral sine inverse, we choose u. This is inverse trigonometric, so layet I. So I choose u equals sine inverse x. And if you remember the derivative of sine inverse, it's 1 over square root of 1 minus x squared. The remaining part is dx, choose it as dv, take the integral of both sides, then v would be equal to x. So this integral I now is equal to u times v, which is x times sine inverse x minus integral v du. So x times 1 over square root of 1 minus x squared, or I just can write it x over square root of 1 minus x squared dx. Now, how to find this integral? If I call this integral double I, call it double I, okay? Let me evaluate this integral here. So I'll take u equals 1 minus x squared. I'll solve this integral by substitution, taking u equals 1 minus x squared because the derivative of 1 minus x squared is already there. So negative 2x, that's the derivative, dx. So now the integral I would be, I have already x, but I need negative 2x. So I multiply by negative 2 and divide by negative 2 outside, times dx over square root of 1 minus x squared. Well, this would be negative half times integral of negative 2x dx is just du over square root of u. This would be negative half times integral u to the power half. When you take it up, it would be u to the power negative half du, and integral of u to the power negative half is u to the power half over half, or times 2. So negative half times 2 is negative 1. U to the power half, I can write it square root of u, but u is 1 minus x squared. So this is the integral. So the final answer now would be x sine inverse x minus double I, which is minus this. So minus times minus would be plus 1 minus x squared plus c. So this is the integral of sine inverse x. If you find the derivative of this, you should get sine inverse. Now I have y times e to the power negative y. There is a method we learned to give us the integral easier or faster. The function now we choose as u is y, and the function we choose dv here is e to the power negative y times dy. Okay, so why we choose y? Because y algebraic, it comes before exponential in layet. Okay, the last thing is the exponential. Now u is y. What do we do with y? We find its derivative. So what's the derivative of y? It's 1. Derivative of 1 is 0. So you find the derivatives of this function until you reach 0. If the derivatives of of this function cannot reach 0, then you cannot use this method. So this method, always u here is an algebraic function that ends, its derivative would be the third or the fourth or the fifth would be 0. Now, what is the integral of e to the power negative y? Well, remember, integral of e to the power x dx is e to the power x plus c. So the integral of e to the power, if you have ax plus b dx, then the integral would be 1 over a times e ax to the power ax plus b, of course, plus c. So remember this formula well, because you will need it here. So here e to the power negative y, so a is negative 1. So the integral would be e to the power negative y over negative 1, or multiplied by negative 1. And then the integral of this, the minus sign is there, and the integral of e to the power negative y is again e to the power negative y over minus 1, or multiplied by a minus 1, but there is another minus 1 here, so minus times minus is plus. So the integral of negative e to the power negative y would be e to the power negative y. Then you write here positive, negative, positive. You start always by positive, and you go alternatively, and you multiply this times this and this times this. This would give you the answer of this integral. So this integral would be equal to negative y e to the power negative y, then negative 1 times e to the power negative y plus c. So this would be the integral. Here also, pi minus x is uh, an algebraic function, and the derivative of pi minus x is negative 1, because the derivative of pi is 0, it's just a number, and the derivative of negative 1 is 0. So we can use the same method. But how to find the integral of cosine pi x? Well, similar to e, we know that integral of cosine x is sine x plus c, because the derivative of sine is cosine. Okay, of course there is a dx here. So what would happen if I want to find the integral of cosine ax plus b, not just x? So the answer here would be 1 over a sine ax plus b plus c. So remember also this formula. So whenever you replace x by ax plus b, you just find the same, use the same formula, but you should divide by a. So the integral of cosine pi x is sine pi x over pi. And the integral of sine pi x is negative cosine pi x over pi, and there is already pi here, so pi square. So that's the integral of sine pi x. It's negative cosine pi x over pi. Now you write plus minus plus, and you multiply this times this and this times this. So this integral would be equal to pi minus x times this, so I write it over pi times sine pi x. Then minus, there is a minus here. Minus times minus is a plus. Then times this minus is minus. So minus 1 over pi square cosine pi x plus c. This would be the answer of this integral. Now here I have a logarithmic function ln x and algebraic. Layat starts with logarithmic, so I immediately choose u to be ln x. So u here is not the algebraic, u is ln x, and du would be 1 over x dx. Well, dv would be 1 over x squared dx, or x to the power negative 2 times dx. And by this integral is 1 over x squared times ln x dx. So ln x is taken as u, and 1 over x squared dx is taken as dv. It's a big mistake here to take x squared dx as dv. X squared is not multiplied by dx. So x negative 2 is multiplied by dx. So to find the integral of v is integral of this, which is x to the power negative 1 over negative 1, or simply negative 1 over x. So this integral, let me call it I. So I would be equal to u v, so negative ln x over x, okay, minus integral v du, this times this, which will give you negative 1 over x squared dx. And then I can write it negative ln x over x plus integral of x to the power negative 2, which is again negative 1 over x plus c. You can write the negative here, okay? This would be the final answer, and in simplest form. I have ln here, okay, ln square root of x. Well, I choose u to be the logarithmic function and v to be the remaining part, which is dx. So v is x. But what is du? Du is the derivative of ln square root of x, which is 1 over square root of x times the derivative of square root of x, which is 1 over 2 square root of x dx. So actually du is 1 over 2 square root of x times square root of x is x dx. So this integral, which is I would be equal to uv, so x ln square root of x minus integral of v du, v du, x times 1 over 2x, x times 1 over 2x dx. X cancels with x, and the answer would be x ln square root of x minus integral half, which is half x plus c. Of course, here you could have taken, you could have written this as ln x to the power half, and then you take half here, because this is a property of the logarithmic functions. So then you find integral of half ln x, or half integral ln x, and make sure it would be equal to this result. I have logarithmic and algebraic. Layet starts with L. So logarithmic before algebraic. So I have to take the logarithmic function as u. Then du would be the derivative of this, which is 1 over t dt. And dv would be t to the power 4 times dt. And v, the integral would be t to the power 5 over 5, and then this integral, which is I, would be equal to u times v. So 1 over 5 t to the power 5 ln t minus integral v du. So it's 1 over 5 t to the power 5 times 1 over t dt. And here I can take 1 over 5 outside, and this would be t to the power 5 over t, that's t to the power 4. And the integral of t to the power 4 is t to the power 5 over 5. Or I can just write this 5 square, or 25 plus c. So this would be the answer. I have only tan inverse here, inverse trigonometric, so I take it as u. Now, what would be the derivative? The derivative of tan inverse is 1 over 1 plus x squared. What is inside tan, you have to square it. So this is 2y, you raise it to the power 2. So you get 4y squared. And then you multiply times the derivative of 2y, which is 2. And I'm going to write it here. So this is the u. And dv would be dy, integral of v, the integral would be v equals y when we integrate. So this integral is I, and I is equal to uv. So it's y times tan inverse of 2y minus integral v du. So when I multiply y by this, I have 2y over 1 plus 4y squared du. And let me call this integral double I and evaluate it here to the right. So how to evaluate this integral? I will take u as 1 plus 4y squared. So I'll use substitution, okay? If I do that, then du, the derivative would be 8y dy. Well, what I have is 2 times y. 2 times y, but I needed 8 to be 8. So I'll multiply by 4. So I'll have 8y after I multiply it by 4. So I divide outside by 4. And I still have here 1 plus 4y squared. So this integral would be changed into 8y dy is du, and 1 plus 4y squared is u. So the integral would be 1 over 4 ln absolute value of u, or ln absolute value of 1 plus 4y square. So this integral would be equal to y tan inverse 2 pi minus this one, which is negative 1 over 4 ln 1 plus 4y square is always positive, so there is no need to write the absolute value. Plus c, this would be the integral. I have t and cosecant square. T is an algebraic function. Uh, its derivative would be 1 and then 0. So it goes to 0. So we can use this method. And dv would be cosecant square t. Well, what is the integral of cosecant square? Integral of cosecant square is negative cotan because uh, the integral, because the derivative of cotan is negative cosecant square. And now we need to have the integral of cotan. And to find the integral of cotan, we write it as cosine over sine. We know that cotan x is cosine over sine, while tan is sine over cosine. And then we take u as sine x. And then du would be derivative of sine, would be cosine x dx. So this integral would be equal to, let me call this double I. So double I would be equal to integral cosine x dx is du over sine x, which is u. So ln absolute value of u or ln absolute value of sine x. Of course, there is a plus c, but we'll use it here. So integral of negative cotan would be negative ln absolute value of sine x. All right. So now I write plus minus plus, and I multiply these two. And this will give me this integral, which is I. So I would be equal to. This times this will give you negative t cotan x. Well, there is no x. Everything is, t here is the variable. So we have always t, okay? Mm. Well, keep this x, no problem. This is not the same question. So from here, I know that uh, cotan t, the integral of cotan t is negative ln sine t. That would be okay. So negative t cotan t minus times minus is plus ln absolute value of sine t plus c. This would be the integral of t times cosecant square t. I have x, it's an algebraic function. Its derivative is 1 then 0. So I can use this method. And I have here cosh ax. Well, we know that the integral of cosh x dx is just sinh x plus c. So what would happen if he asks me to find cosh of ax plus b dx? Then it would be the same integral sine, oh sorry, sinh ax plus b plus c, and I just divide by a. So the integral of cosh ax would be 1 over a sinh ax. And the integral of sinh ax would be cosh ax over a, and there is another a here, so it would be 1 over a square. And I have plus minus plus, and this integral which is, I call it I, would be equal to x over a sinh ax minus 1 over a square cosh ax plus c ln x to the power 2. Well, I have to take u as ln x to the power 2. du here would be the derivative of this, we will use chain rule. So it's 2 times ln x times the derivative of ln x, which is 1 over x. So I'll just divide by x and multiply by d of dx here. Okay, so that's the derivative of ln x squared. dv is dx, so v is x. Now this is I. I would be equal to uv, so it's x times ln x to the power 2 minus integral of v du. Well, when I multiply v by du, x cancels with x. So I have 2 ln x dx. And of course, this 2, I can take it out. So now the original integral was ln x to the power 2, and the new integral is ln x, which is easier to evaluate. This integral, I'll call it double I, and I can find it here. Integral ln x dx. We have found it before anyway. Also, we use integration by parts. I take u equals ln x, and du would be 1 over x dx, and dv would be dx, and v would be x, and I would be equal to uv, which is x ln x, minus integral v du. And notice that x times 1 over x is just 1. So actually, double I is x ln x minus x. All right. So the integral would be x times ln x square and minus 2 times this. So it would be negative 2x ln x, and minus 2 times minus x would be plus 2x plus c. This would be the integral of ln x to the power 2. Well, this integral, if you like, I can write it integral of z times 10 to the power negative z dz. All right. And I will call it I. And then the function z is an algebraic with derivative 1, then 0. And the function 10 to the power negative z. Now, what is the integral of 10 to the power negative z? Well, the integral of b to the power x dx is b to the power x over ln b plus c. What would happen if I use ax plus, let us see, d, any number here, okay? Replace x by ax plus d. The integral would be b ax plus d over ln b and of 1 over a, also over 1 over a. So there is an a here, the derivative of ax plus d plus c. So pay attention. When you find the integral of 10 to the power negative z, it is 10 to the power negative z over ln 10, but there is a negative sign, so multiplied by minus sign. And now negative 1 over negative ln 10 is there, forget about it, and find the derivative of the integral of 10 to the power negative z, because this is just a number. The derivative of the integral of 10 to the power negative z is again 10 to the power negative z over ln 10. So this would be square, and over minus 1, so this would be cancelled. So it would be 10 to the power negative z over ln 10 to the power 2. And now I write plus minus plus and multiply. And this integral I would be equal to z times this. So I will write it negative z 10 to the power negative z over ln 10. So I took the minus sign up. It's okay, I can do that. And minus 1 times this would be negative. I have 10 to the power negative z over ln 10 to the power 2 plus c. We know this integral whenever I have trigonometric with exponential. We said this is a strange integral. So trigonometric before exponential in layet, okay, because e exponential is the last letter. So I will use u as cosine to theta. So du would be the derivative of cosine, which is negative. Sine 2 theta times 2, or negative sine, negative 2 sine 2 theta d theta. And dv would be e to the power negative theta d theta. And the integral of e to the power negative theta is e to the power negative theta over minus 1. So this integral I is equal to uv, so negative e to the power negative theta cosine 2 theta minus integral v du. Minus times minus is plus, and there is a 2, so I write it outside. And there is e to the power negative theta times sine 2 theta d theta. All right. And let me evaluate this integral. Let me call it double I and evaluate it here. So to evaluate double I, which is integral of e to the power negative theta sine theta d theta, I do it also by by parts. So I take u equals to sine 2 theta, trigonometric. Then du, the derivative of sine is cosine. So cosine 2 theta times 2 d theta. Well, dv would be e minus theta d theta, and v is the integral of e minus theta, which is the same multiplied by minus. So I would be equal to negative e to the power negative theta cosine theta minus 2 times, okay, I did not find double I. Double I would be uv, so negative e negative theta sine 2 theta minus integral. Now this times this. There is a negative 2, so this would be positive 2, okay? E negative theta cosine 2 theta d theta. Well, notice that e negative theta cosine 2 theta d theta is the original integral. So it's I, okay? So I will write it negative e negative theta sine 2 theta plus 2I. This is I. So here now I would be equal to negative e negative theta cosine 2 theta. This should be 2 theta minus 2 times this. So minus 2 times negative would be positive 2 e to the power negative theta sine 2 theta multiplied by then negative 2 times 2I, so it would be negative 4I. So now the integral I can, this is negative 4I and this is I can take negative 4 to the other side. So I will have 5I equals this. and then I can write that I is 1 over 5 times this one. Okay, so I would be 1 over 5 times negative e to the power negative theta cosine 2 theta plus 2e to the power negative theta sine 2 theta plus c. So this would be the integral of e to the power negative theta cosine 2 theta. Here I have z cube. It's the function that I'm going to choose as u and find its derivative, and its derivative will end up with 0. Okay, 3z squared, 6z, 6 and 0. While Ez would be dv, Ez dz. Integral of Ez is the same function again and again. So I write here plus minus plus minus plus. And this is the integral I, and let us write the answer. So I is equal to z cubed times e. Yeah, let me do this one. Okay. So z cubed times ez minus 3z squared ez. We can take ez common factor, by the way, plus 6z times ez minus 6ez plus c. So that's the integral. Here also I have 1 plus x squared is a function, algebraic function, in which its derivatives goes to 0. So the first derivative would be 2x, the second 2, the third is 0. While dv now is e to the power 3x. So the integral is e to the power 3x but over 3. And the integral here is e to the power 3x over 3. 3 times 3 would be 9. And the integral here would be e to the power 3x over 3. 3 times 9 would be 27. And I have plus, minus, plus, minus. And I multiply like this. And this integral, which is I, would be equal to 1 plus x squared over 3 e to the power 3x minus 2x over 9 or 2 over 9 x e to the power 3x, then plus 2 over 27 e to the power 3x plus c. This is an additional exercise. It has an idea. You can think about it if you like. You can pause the video and think about it. This, I think, will take some time of you to realize that u here should be taken as x times e to the power x. And the derivative, we will use the product rule. The derivative of x is 1 plus x times the derivative of ex, which is the same, times dx. And we will take dv here to be x plus 1 to the power negative 2, or 1 over 1 plus x to the power 2 dx. And what would be the integral? Well, remember that the integral of x to the power n dx is x to the power n plus 1 over n plus 1 plus c. What if the question is integral of ax plus b to the power n? Then the answer would be ax plus b to the power n plus 1 over n plus 1 over a, okay? Or we divide by 1 over a as usual, plus c. So the integral, because a here, the coefficient of x is 1, so the integral in fact would be x plus 1 to the power negative 1 over negative 1 or negative 1 over x plus 1 simply. Notice that this is a definite integral. Let me call it I. So I would be uv. So it's negative x e x over x plus 1 from 0 to 1 minus integral v du. Notice that there is a minus sign, so it will make this plus. And then I'll have ex plus x ex over x plus 1 dx. And notice that this integral, which I'm going to call it double I, is in fact very simple because you can take ex as a common factor from the numerator. And then you cancel x plus 1 with x plus 1. And then the integral of ex is ex plus c. So that's it. So uh, from 0 to 1. Yeah, from 0 to 1. So it's from 0 to 1. So it's from 0 to 1. So e to the power 1, which is e, minus e to the power 0, which is 1. So that's the answer. And here, if you replace x by 1, I get negative e to the power 1, okay, over 1 plus 1, which is 2, minus, if you replace x by 0, you get 0 over 1, so 0, okay? So plus e minus 1. So that's the answer of this integral, the exact answer. Use the method of cylindrical shells to find the volume generated by rotating the region bounded by these curves about the given axis. All right, let us sketch the graph. We know the graph of y equals e to the power x. It's like this. E to the power negative x, we also know the graph. It's like this, okay? And x equals 1. This is x equals 1. It goes like this. So where is the region bounded by these three curves? It's this region. We need to rotate this region about the y-axis. Well, uh, yeah, I should notice that this curve is above this curve, above this curve. So y equals ex is above y equals negative x in all the region, okay? So I need to take here a rectangle which is vertical. So the width of the rectangle would the length of the rectangle or the height of the rectangle would be this minus this. And when I move the rectangle in all the region, always e to the power x is above e to the power negative x. If you choose uh, a, a horizontal rectangle here, then it's a problem and you need to divide the area into two regions because there is no always a curve which is to the right of the other one. So if I decide to use a vertical rectangle, this means the rectangle is parallel to the y-axis and I should use method of cylindrical shells. So anyway, he asked me to use method of cylindrical shells. So he is asking about the easiest method to solve this question. So the volume by cylindrical shells is given by V. The volume equals integral of 2 pi. Here, the width is delta x. So 2 pi x f of x dx, where x is uh, radius of the radius of the cylinder which is represented by this region, because we will rotate about the line, uh, the x-axis. So this region is in fact uh, x, because this point has coordinates x and y. So it is x, and f of x is the height of the rectangle, and the height of the rectangle is ex minus e to the power negative x dx, integral from 0 to 1. And now we need to use uh, integration by parts, okay, to find this integral. I can divide this into two integrals, 2 by x ex minus 2 by x e negative x, but I will work with it like this, okay? Uh, so I'll take u as x because it's algebraic and these are exponentials. So du would be dx. And I'll take dv as ex minus e to the power negative x dx. So taking the integral of e to the power x is e to the power x. And integral of e to the power negative x is e to the power negative x over minus 1. So it will make this positive. So v would be equal to v times u, so x times ex plus e to the power negative x from 0 to 1 minus integral v du, so ex plus e minus x dx from 0 to 1. If I replace x by 1, okay, I have 1 e to the power 1 e plus e to the power negative 1 or 1 over e minus 0. X is 0, so it will destroy everything. Now here, the integral, this integral, let me call it double I. So double I equals. In ex, the integral of ex is ex my plus the integral of e negative x is e to the power negative x over negative 1. So this plus would be minus from 0 to 1. So e to the power 1 is e minus e to the power negative 1 is 1 over e minus e to the power 0 is 1 minus e to the power negative 0, which is 0, which is again 1. So this would be cancelled. So I will have e plus 1 over e minus this one. All right. So the final answer would be e plus 1 over e minus e plus 1 over e, because minus will change the minus into plus. So the answer would be 1 over e plus 1 over e, or just 2 over e. This would be the volume of this solid of revolution when revolved about the y-axis. Another question. Let us try to graph the region. I have e to the power x again. X to the power 0 is this line, the y-axis, and y3, 1, 2, 3. So this is y equals to 3. So where is the region? It is this region, okay? We need to rotate this region about the x-axis. Well, which is better? Uh, uh, yeah, it is okay because the line is above the curve always, and this curve is to the right, okay? So I can use both. But he said cylindrical shells, so I have to choose a rectangle which is parallel to the axis of rotation. and the volume would be given by integral 2 pi. In this case, the width of the rectangle is delta y. So the radius would be y, and the length of the rectangle would be in terms of y. And y is from 1 to 3. So it would be integral from 1 to 3, 2 pi. I think I forgot something here. Yeah, I forget the 2 pi. I did not take 2 pi into consideration. So there are always, the 2 pi are always there. So the volume is 2 pi times everything, okay? So it is here also, 2 pi times everything. So again, it is here times 2 pi and times 2 pi. To the answer is 4 pi over E. This should be the answer. So here 2 pi times, well, y is the radius of the uh, cylindrical shell, which is, yeah, it is y. This distance is y. And the height of the rectangle would be this curve minus this one. Well, this is x equals to 0, and this one I need to solve it in terms of x. It is y equals to e to the power x. To solve it in terms of x, x would be uh, ln y. All right. To solve this, if you want, you can apply ln to both sides. Len cancels e, and x would be the len of y. So the height of the rectangle, okay, or the length of the rectangle would be this minus this. So lny minus 0, or just lny, and don't forget the radius, which is y dy. And now how to find this integral y ln y? I should use integration by parts. And of course, I have algebraic logarithmic, so we take u as ln y. So du would be 1 over y dy, and I take dv to be y dy, and then v would be y square over 2, the integral of y. So v would be equal to 2 pi, all right, times. Now, u times v, which is y square lny over 2 from 1 to 3 minus integral 1 to 3 v dy. So y square over y, and there is a half. I can take the half outside, and this is y square over y, so that's just y. So let me call this double I and evaluate here. It is y square over 2, because the integral of y is y square over 2 from 1 to 3. So actually it is 9 over 2 minus 1 over 2, 8 over 2, which is 4. So the volume would be 2 pi times. Replace y by 3, 9 ln 3 over 2 minus 1 ln1. ln1 is 0. So this would be cancelled. So minus half times 4. So 2 pi times 9 ln 3 over 2 minus 4 over 2, which is 2, and this would be the final answer. You can expand 2 over 2, so 9 pi ln 3 minus 4 pi. You can write the answer like this. calculate the average value of this function on the interval. Well, we know that if average by definition is 1 over b minus a, or pi over 4 minus 0, so it's just pi over 4, integral from 0 to pi over 4 f of x, which is x secant square x dx. Well, how to find this integral? We use integration by parts. And luckily, we have u as the function x, which has derivative 1, then 0. And dv is secant square x. Well, integral of secant square is tan x, because the derivative of tan is secant square. And to find the integral of tan, I think we should memorize the integral of tan, because it may come a lot, but we can find it quickly by writing it sine over cosine, and then we choose u as cosine, and du would be negative sine x dx by substitution. So you put minus here and minus here, so it would be negative integral of negative sine x dx is du over u, so it would be negative ln u, or negative ln absolute value of cosine x. So we can just write it negative ln absolute value of cosine x. And now I have here plus minus plus, and I multiply these, and this would give me the answer. So I have 1 over pi over 4, or you can say 4 over pi times x times tan x. Okay, you can write here from 0 to pi over 4, or continue and take them together, it's okay. Negative 1 times this, negative times negative would be plus ln cosine x from 0 to pi over 4. And the answer would be 4 over pi. Now pi over 4, tan pi over 4 is just 1, minus 0, so this would be cancelled, plus. Now cosine pi over 4 is square root of 2 over 2. So I have ln square root of 2 over 2. Can use the calculator for that. And minus cosine 0 is 1 and ln 1 is 0. So this would be also cancelled. So the final answer would be 4 over pi times pi over 4 is 1, plus 4 over pi ln square root of 2 over 2. This would be the answer of the question. And I believe this is the last question. Hopefully you enjoyed integration by parts and its exercises.